Good afternoon, class. Today we're going to tackle about relations and functions. Okay? The following objective of this course is to understand that a function is a rule that assigns to each input exactly one output. The graph of a function is the set of ordered pairs consisting of an input and the corresponding outputs. Compare properties of two functions, each represented in a different way, algebraically, graphically, numerically, in tables, or by verbal descriptions. For example, a given linear function represented by a table of values and a linear function represented by an algebraic expression. Now we're going to determine which function has the greater rate of change. We have the following essential questions to suffice the objectives. What is a function? What are the characteristics of a function? How do you determine if a relation is a function? How is a function different from a relation? Why is it important to know which variable is the independent variable? So we have the following definitions. A relation between two variables, x and y, is a set of ordered pair. Okay? An ordered pair consists of an x and y coordinate. A relation may be viewed as ordered pairs, mapping design, table, equation, or written in sentences. X values are input independent variable or domain. And then we have your Y values are output dependent variable range. Okay. If you are given in an equation, the X part is defined as your independent variable or domain. And then the Y is your dependent variable and range. Okay. So we have this first example. What makes this a relation? We are given with the following set of coordinates as 0, -5, 1, -4, 2, -3, 3, -2, 4, -1, and 5, 0. First, to determine if this is a relation, we have to identify which are the domain and which are the range. I repeat, when we say range, those are the Y values. And then domain, those are the X values. So we are given with X, Y coordinate pairs. Now to determine now the domain, we're just going to identify the X values. So we have to reveal the answer now as 0, 1, 2, 3, 4, and 5. And then for the range are those remaining Y coordinates, given as -5, -4, -3, -2, -1, and 0. Is this a relation? So we have the input values as for -5, 0, 9, -1. And then we have the output values as -2, 7. When we say input values, those are the values that corresponds to the dependent variable. Hence, it affects the dependent variables. So when we say in an equation given as y as a function of x, your domain now is the x and your relation is the y. Okay? So your input defines as for -5, 0, 9, -1 for this example, and then for the range, which are the output or the y as -2 and 7. Is a relation a function? What is a function? According to a textbook, a function is defined as a relation in which every input has exactly one output. Okay? I repeat, every input has exact one output. Focus on the x coordinates. When given a relation, if the set of ordered pairs has different x coordinate, it is a function. When a given relation, if the set of ordered pairs has different x coordinate, it is a function. If the set of ordered pairs has same coordinates, it is not a function. If the set of ordered pairs has same coordinates, it is not a function. Y coordinates have no bearing in determining function. Okay. Example 3, we are given again with the following coordinates. We have the following question. Is this a relation? Is this a function? So it is a relation because sufficed the definition earlier. It is also a function, okay? Why? Look only at the x coordinates. You can see the x coordinates are 0, 1, 2, 3, 4, and 5. Example number 4, we are given with the new set of coordinates, -1, -7, 1, 0, 2, -3, 0, -8, 0, 5, -2, and -1. Is this a function? Okay, again, let's look for the x coordinates as -1, 1, 2, 0, 0, -2. So it is not a function because it has a repeating x coordinate values, namely as 0, 0. Okay. And then it's only 0, 0. Is this still a relation? Yes, of course. So which relation mapping represents a function? Is it the first choice or the second choice? Let's reveal the answer. So we have your answer as your first choice. Okay. Which relation mapping represents a function? Is it A or B? Let's reveal now your answer. It's letter B. Okay. For a function to be a function, your domain must have one range. Okay. Vertical line test. A relation is a function if a vertical line drawn through its graph passes through only one point. Okay. For pencil test, take a pencil and move it from left to right, -x to x. If it crosses more than one point, it is not a function. I repeat, if failing the pencil test, if an equation graph fails a pencil test, it is defined as it crosses more than one point. Okay, it is not a function. So what types of graph that fails the pencil test or vertical line test? We have the following as your hyperbola, okay, your ellipse, and circles. Your parabola that opens either right or left fails this test as well. Okay, so let's proceed with this example. Would this graph be a function? Okay, we are given with this diagonal linear graph. This actually y is equal to x. So if we going to pass through the pencil on this line from -x, okay, to your positive x, and it has only one point. So this linear equation passes the vertical line test. Okay, so it's a yes. Would this graph be a function? So it's a yes. Okay. About this one, we are given with this ellipse. Let's test this. Okay, we have one point there, but we got 2 points. So again, this is not already a function. It failed the vertical line test because the whole graph has 2 coinciding points. Okay. Is the following function discrete or continuous? What is the domain? What is the range? So This is a discrete type. Your domain now, I repeat, your domain are the x coordinates. We have your -7, 1, 5, 7, 8, and 10. Your range now are the y coordinate as 1, 0, -5, -7, 5, and 2, 8. Okay. Is the following function discrete or continuous? What is the domain? What are the range? So this is a continuous because it has lines. The domain now are your x coordinates of the coordinates of the graph as -8 and 8. Your range are the y coordinates as -6 and 6. Is the following function discrete or continuous? What is the domain? What is the range? It is continuous because it's linear. The domain points are 0, 45, and your range here are 10 and 70. Is the following function discrete or continuous? What is the domain? What is the range? This is discrete because it is a parabola. And then we have the domain. If we're going to examine per points, the x coordinates of each point defines the domain as -7, -5, -3, -1, 1, 3, 5, 7 for this graph. Okay. And we have the following range. To define your range in this parabolic graph, we're just going to identify the y coordinates of each points given as 2, 3, 4, 5, and 7. Which situation represents a function? Letter A. The items in a store to their prices on a certain date. Or letter B. Types of fruits to their corresponding colors. Okay, the answer now is letter A. Why? There is only one piece for each different item on a certain date. The relation from items to price makes it a function. The explanation for letter B, which is not a function, a fruit such as an apple from the domain would be associated with more than one color, such as red and green. The relation from types of fruits to their color is not a function. Domain and range in real life. So we have the application of the following. The number of shoes in X pairs of shoes can be expressed by the equation y is equal to 2x. What is the independent variable? Okay, the variable that can be changed. We have the x, okay, the number of pairs of shoes. Then, what is the dependent variable? It is the y, the total number of shoes. Okay. Domain and range in real life. Mr. Landry is driving to his hometown. It takes 4 hours to get there. The distance he travels at any time t is represented by a function d is equal to 55t. His average speed is 55 miles per hour. What is the independent variable here? The time that he drives, okay? And then the dependent variable here is the distance, or d. Domain and range in real life. Johnny bought at most 10 tickets to a concert for him and friends. The cost of each ticket was $12.50. Complete the table below to list the possible domain and range. So in this analysis, we are given with the for your upper rows as 1, 2, and 3, and then the corresponding variables 12.50, 25, 37.5, 4, 1, 2, 3, respectively. For your fourth now, how are we going to get the values? For your fifth, sixth, seventh, eighth, 9, and 10. So for the 4, we get 50, 62.5, 75, 87.5, 100, 112.5, and 125, 4, 6, 7, 8, 9, 10, respectively. What is the independent variable here? So your independent variable here are the number of tickets that were bought. Okay? And then what is the dependent variables here? The total cost of the ticket. Each pizza parlor charges $5 for a large pizza with no toppings. They charge an additional 1.50 for each of their 5 specialty toppings. Tax is included in the price. So what is the independent variable? The number of toppings. Okay. What is the dependent variable? The cost of the pizza. So that ends my presentation for relations and functions. I hope you enjoyed it.